What's going on, everybody? Welcome back to my YouTube channel. This looks like a fun one. We're told to look for the value of m, which satisfies m to the power of 3 plus 5m equal to 42. Well, we're not just going to be looking for just one value of m. We're going to cover all the values of m, both complex and real values. So what is the first step to take? We are to move 42 to the left hand side so that we have m to the power of 3 plus 5m, and as 42 crosses to the left, it becomes minus 42. This is equal to 0. Now our next step will be for us to distribute this 42. We're going to sum two numbers to give 42, such that one of the numbers must be a perfect cube, just like this. So we have m cubed plus 5m minus, now the sum that I'm going to get is 27 plus 15. So 27 is a perfect cube like m cubed. So this is equal to 0. Now this can further be simplified into m cubed plus 5m minus, now 27 can be written as 3 cubed plus 15 equal to 0. Now our next step will be for us to use this negative to open up the bracket. So we have m cubed plus 5m. Now this becomes minus 3 cubed. Now negative times positive is negative 15. This is equal to 0. Now we're going to bring the cubes together. So this is m cubed, and I'll bring negative 3 cubed close to it, and then I write plus 5m, then minus 15 equal to 0. Now notice that the first two terms we have difference of two cubes. Difference of two cubes has identity of, for example, when I have x cubed minus y cubed, this can be written as x minus y times x squared plus xy plus y squared. Now we're going to be applying this to what we have here. Now writing this is like our x and this is like our y. So this will be m minus 3, just like this, times m squared plus 3m plus 3 squared. That is it. And then we have plus. Now notice that 5 is common, so we can factor out 5. Now 5m divided by 5 is m minus, and then 15 divided by 5 is 3. Good. And this is equal to 0. Now we know that 3 squared is 9, so I'm going to be putting 9 here instead for simplicity. So this is 9. So now we're going to factor out m minus 3 because it is common. So I factor out m minus 3 and then open a bracket. Now this divided by m minus 3, I'm going to have m squared plus 3m plus 9. And then plus this divided by this, I'll have 5. So plus 5 equal to 0. So we have two cases, but I'm going to simplify this. This is 9 plus 5, which gives 14. So I'm going to be putting 14 here. So this will be 14 instead. So the two cases we have m minus 3 to be equal to 0, or we have m squared plus 3m plus 14 to be equal to 0. For the first case, we can get the value of m by moving negative 3 to the right hand side, and when we do that, we have m to be equal to positive 3. For our second case, we have a nice quadratic equation, but we're going to be using the quadratic formula to solve this. Here in our quadratic equation, our a is 1, our b is 3, and then our c is 14. And a quadratic equation formula we're going to be using will be, we're looking for m. M is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's substitute here. So m will be negative b, so that will be negative 3 because b is 3, plus or minus the square root of 3 squared minus 4 times a is 1, times c is 14, all over 2a, so that is 2 times 1. So simplifying further, m will be negative 3 plus or minus the square root of 3 squared is 9 minus 4 times 1 times 14 is 56, all over 2 times 1, that is 2. Now simplifying further, m will be negative 3 plus or minus the square root of 9 minus 56 is negative 47, all over 2. Now we can simplify what we have inside of the radical. So we have m to be equal to negative 3 plus or minus. So this can be written as 47 times negative 1 all over 2. And can further be simplified into, we have negative 3 plus or minus. This can be written as the square root of 47 times the square root of negative 1 all over 2. Now we know that the square root of negative 1 is I, which is iota. So that means our m will be negative 3 plus or minus, now the square root of 47 times I all over 2. Now let's separate the two values of m from here. So we have m to be equal to negative 3. We'll go with the plus first, plus the square root of 47i all over 2, or m is equal to negative 3. This time we'll go with the minus, which is the negative, minus the square root of 47i all over 2. Now writing it in a more modern way, we have m to be equal to, this is negative 3 over 2, plus, now I'm going to be writing this I first, so I root 47 all over 2. The same thing with this, so this will be m equal to negative 3 over 2, now minus I root 47 all over 2. And this is our final answer. So we have two complex solutions of x, and we have one real solution for m, which is m equal to 3. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.